Greetings and welcome to the world of Mathematics 3. You have stumbled upon the best part of the internet. That's right, where you can learn about math. And we are here at the beginning of our Math 3 course. The first thing we're learning today is about solving equations. And before we even get there, we're going to talk about translating from English to matemáticas. Actually, I just said math in Spanish. That's not very helpful. From English to math. That's more helpful. So what we're going to talk about is kind of just some of the words used to describe different operations and relationships and numbers and variables, all within the realm of math. So here we go. So let's translate these into this. So these are sentences, and I'm going to translate them into equations, or in some cases, inequalities. All right? So this first one, it says, a number plus 7 is 2. So let me help you out with the first part. It says a number, that's going to be some unknown value to us, right? I don't know what number that is yet, so I'm going to give it a name. And in math, that's probably going to be some sort of a variable, all right? And often the names we pick for variables are lowercase letters, and X is the one that most mathematicians are fans of. By the way, sometimes there'll be X sub 1 or X sub 2 or X sub 7. So that's a possible way to make some distinctions with your variables as well. So stuff like that can happen. So a number plus 7 is 2. So let's see, how could I write this? Well, plus what operation does that imply? Addition. 7 is implying the number 7. That's not bad. What does is mean? Equals. And 2. So there we go. I've successfully translated a English sentence into a math equation. All right? Now, let's say that it ended right before this is here. Now, this would be a sentence fragment because I just erased the verb is, right? And a sentence fragment would translate into a mathematical expression. So an equation includes an equal sign. An expression is just some sentence fragment, essentially, is what's going on there. All right, so a number plus 7 is 2. A number plus 7 is 2. So let's check out this next one. 5 more than. Okay, so I read that. Some people might assume that means this, 5 plus something. And technically, mathematically, they're not wrong. But in order to have the most literal translation, it's 5 more than something. So that means I'm adding 5 to something else, right? 5 more than wherever I started, right, is the idea. And that's kind of like, for most of this, we'll try to have the most literal translation. Kind of reminds me of in Spanish, how I might say like, perito rojo y gordito. Gordo. And basically all of the adjectives come after the nouns in Spanish, whereas in English we might say the fat red dog, where the noun came at the end and all the adjectives came prior. So in this case, we're going to try to stick with just the most literal translation. So 5 more than means I'm adding 5 to something. And what am I adding it to? 3 times the number. So what does times imply? What operation? Multiplication. So this would be 3x plus 5. Now, let's see. Is greater than 10. So greater than 10, does that mean I'm adding 10? No. Well, didn't more than just a moment ago mean plus? But the is showed up. And is means there's going to be a relationship. Like is here meant equal. So is greater than. So this is a relationship, not an equal sign in this case, but a greater than symbol is greater than 10. Like so. What's another way I could have read this out loud? Or just the first half? Anybody? What's another way we could say that? Yeah, 3 times x, or 3 times a number plus 5, right, is more than 10. Yeah, that would work. That would work. Sure. So there's multiple ways you could say things. Let's see. How about this one? 6 less than half a number. So what does this less than mean? Subtraction. How do I know it's not this less than? Because what?
It's giving you a number.
Well, I can't have 6 is less than half a number.
It doesn't have is in it.
It doesn't have is in it. Okay, very key. Good catch. So what does less than in this case mean? Subtraction. And am I doing this? Right. So 6 less than something means I'm subtracting 6 from something, and I'm subtracting it from half a number. I could write that as 1/2 x. That's fine. I also could have written that as x over 2. That's another way you could write it. I kind of like the 1/2 x myself, but it doesn't matter in that case. Let's see, is, that's equals, 5 times the number minus 1. So 5 times the number minus 1. Okay. Now, how do I know I didn't mean this? 5 times parentheses the number minus 1.
You would say the number minus 1 times 5.
The number minus 1 times 5 would look like that. We'll come back to that concept in a moment. But this is the correct interpretation, right?
Would you like x minus 1 and then times 1?
It would need some more language than that. But we'll talk about that in a moment. I just want you to realize there's a need for some way to describe that.
Wait, is that x times, or is that supposed to be an x? Oh.
Yeah. A lot of times in algebra, you won't see a multiplication symbol written. In fact, even if I have two variables side by side, that means y times z, or 3 times y times z. So just the fact that those are side by side, it's implied multiplication. And if I was to use a multiplication symbol, I usually would use a dot rather than like a little multiplication x. Yeah, specifically because mathematicians like using x's as variables a lot of times. But it doesn't have to be. Let's see, this next one's a little bit easier. 4 times a number. So 4, I'll use a different variable this time. How about q plus 7 is 9. Okay, so 4 times a number plus 7 is 9, not bad. And this last one, 3 times the sum of a number and 2. Any guesses on how to write that one?
X equals.
X equals?
No, I mean like 3x equals.
What operation does...
It'd be 3 times 3 plus 3x plus n.
Well, the number is my x here.
Okay. Plus 2 is plus n, or do that plus 6.
Okay. Now, it turns out the word sum does not just mean addition. It actually means addition with priority. So what this actually means, when I see 3 times the sum, I think 3 times the sum means addition within parentheses. And then I know that the next 2 things I hear are the things that are being added. So the sum of a number and 2 is less than or equal to 6. And in this case, we happen to have an inequality that was both equal and less. So that means it included 6 and everything less than it, right? Whereas this inequality was everything greater than 10, but not including 10. So the smallest number you can think of that's close to 10, but not yet 10. That sort of idea there. So sum is more powerful than just a plus, okay, or a more than. It means addition with priority. Another way you could read this, by the way, is 3 times the quantity x plus 2. All right, quantity sometimes can be used to represent parentheses. Or I might say x plus 2 all times 3, but that times 3 in that case would have landed on the right side. But it wouldn't have made a difference because multiplication can be done in any order. Does anyone know what rule that allows us to do that? What property? Distributive would be this, but q times 4 and 4 times q are the same thing. Does anyone know what property that is? Or 2 times 3 is the same as 3 times 2? I'm glad you knew distributive. Distributive, I would argue, is the one that is trickiest. These other properties we typically know but just don't know the names of. This would be the commutative property. All right, and I literally think about like, oh, I commute between work and home. I'm changing location. You know, like that's what I like to think of. Commutative. So let's see. I think I've got one more interesting one here that I'd like us to look at. Let me grab a snapshot of it. Oh, this one's so good. It's devious. Doot 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 doot. Here we go. Quotient. I think that means like you're quoting somebody. Oh, division. This one's super tough. Actually, take 5-10 seconds. Write down your guess on this one. In the meantime, I'll whistle a tune for our video watchers on YouTube. And we're back, ladies and gentlemen. So, quotient, what does that mean? Division. Okay. So, by the way, in algebra, typically we don't use the little division sign like this guy. More often we'll use just a straight up fraction bar. Okay. I messed stuff up. Bad. Okay, here's my little writing. There we go. So the quotient of, what am I dividing? I'm dividing 2 and what? A number. And what? Let's see, what's this word mean?
Subtraction.
Subtraction, so I'm subtracting 1?
So no, it's the difference of a number and x minus 1.
X minus 1 like down here hanging out?
Yeah.
Does anyone agree with him?
Yeah.
It's funny because I agree with him as well. Amazing. Let's see. So the quotient of 2 and the difference. When I hear the word difference, guess what I write? Subtraction with priority. Right? Subtraction within parentheses is what difference means. Similar to sum, meaning addition within parentheses. Okay? However, in this case, we actually won't need parentheses because the vinculum is already a grouping symbol. Classic. So let's see. The number in 1. And what do I know? Is greater than 10. So that means I'm adding 10. No, why?
The alligator is
Yeah.
Is greater than 10. Yeah, well, I guess it is like a sideways caret, right? So we could have this. We don't have one of these, though. I guess that's just the letter V. I've got enough to make like a D-pad for some sort of like Nintendo controller, maybe.
Fraction was greater than 10 or 10 greater than fraction?
This is the bigger of the two. So the fraction is bigger than 10. Yeah.
The side that the alligator mouth faces is bigger.
Yep.
Bigger number.
Got confused for a second.
Yep.
Oh,
Or you could think about the Pac-Man.
Waka, 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 waka.
Oh, that's beautiful.
All right, the Pac-Man's heading towards the bigger one. I don't know.
Power bells.
Power pills. Yeah, power pellets or whatever. So, okay, so that's some basic kind of introduction to just some of the language of some words that we'll be using, and it's important for us to kind of know some of that. Actually, one of the things I want to just talk about, what about this? What if I asked you to translate this compared to this?
You add the number and the exponent, and the other one you add the exponents together. Or one here exponent. Oh, that's right, one with the 3.
Well, wait. According to PEMDAS, what would I do first if I knew what the x was?
You multiply and then you
I'd raise to the exponent, which is a type of multiplication, and then I'd add the 1. Here, what would I do?
add the baseline.
I'd add those first, so you could kind of think of those in parentheses. But I just want to point out that the way that I would say this, I would verbally say this one on the left as 3 to the x plus 1. And this one I might say as 3 to the x plus 1. And I might just simply do it by emphasis on a different portion of it, right? So 3 to the x plus 1 versus 3 to the x plus 1. I don't know. Or you could even call this 3 to the x plus 1th power. That's right, I just said 1th. That's awesome. Actually, math has some pretty great things. Like you could have 3 to the jth power. Jth, yeah. Or 3 to the pith power. Yeah. Right? So there's all sorts of interesting things you could do. You also could emphasize this one by saying 3 to the quantity x plus 1, and the quantity would kind of imply that parentheses are there. The worst way to say it, which is still accurate, would be 3 to the open parentheses x plus 1 close parentheses. That's kind of the equivalent of saying, like, if I ask you to read this word, and you're like, oh yeah, I can read that word. That's THAN. And I'd be like, you didn't really read it. You just told me the symbols that made it up. So there's a subtle difference there. But as we learn all sorts of new concepts and stuff, I'll try to familiarize you with the new vocabulary. But it's important that we can communicate effectively as mathematicians. Let's see, here we go. Let's hit our first example. We're going to hit into solving. And typically what I do with examples is I write EX in a little box, and my box is usually kind of sad. It looks like it's cardboard and has been left outside in the rain for a while. So we're going to solve some equations. Let's see. No loop-de-2 for you. So if I want to solve this equation, first of all, my question is, well, actually, all right, here we go. Solving, I'm talking about using a process, all right? Algebra kind of is the process typically for getting a variable by itself, all right? I'm trying to I want to find out what works for x there, right? What numbers could x possibly be? Now, there's this other concept called mental math, where you might see like blank plus 2 equals 9. All right, that'd be like mental math. And the way you would answer that question, even though these are very similar, I'd argue that these are actually the same, but our approach is going to be different. Here I'm interested in the process. Here you're just interested in, I guess, the answer. But in mental math, I just say, what plus 2 is 9? And then your brain would go through its library of mathematical facts, and you'd be like, 5 plus 2 is 7. 6 plus 2 is 8. 7 plus 2 is 9. And then right? And that's what you would do. And that can be okay as far as some intuition you might have for answering that question. But then once I ask you to solve this problem, I don't want you to ever do that with mental math. Right? I hope, in fact, I hope you can't do that with mental math. I mean, maybe it'd kind of be cool on some weird level, but no. I don't want you to be like, let's see, go through my math facts 2/3 times 1 to the square, 1 squared minus 4, is that equal to 10? No. Like, don't do that, right? So that's why I'd rather you learn a process, even though there might be some way, maybe you could guess the answer right away. But learning the process is going to be valuable, so then when you get to something that's more complicated, you'll know how to get through it, right? It'd be like if say, like, we had this little, outdoors class, and we go out on the soccer field, and I'm like, all right, let's find our way to the goal, like the soccer goal. Did I say soccer field? I hope so. Anyways, right? And then you're like, oh, I know where the soccer goal is, and you just, like, walked over there. Well, the rest of the class, I trained how to use, like, compasses and maps. And you're like, well, this is dumb. I already know how to, right? I know how to find the soccer goal. I've been here before, right? However, then when we later, like, end up going, like, out in the wilderness of the Green Mountains, and, like, I gave you a more challenging problem, you're like, oh, no, this is not related to soccer goals anymore. And then you end up getting lost in the wilderness and, like, being eaten by an alligator in the Green Mountains, apparently. Whereas the rest of us, we learned the process, and we were able to figure out where we were going using orienteering and whatnot. So that's my main point. Now, regarding this guy, what is happening to x that made it equal to 9? It's being added by 2. All right? So what I'm looking to do is a way to undo the things that happen to x so I can get it just back down to regular old x. So what undoes addition by 2?
Subtraction.
So I just do this and then I get x equals 9, right? Exactly. You have to do it to both sides. Perfect. And you would end up with these 2's cancel out, and I get x equals 7. By the way, that's called the subtraction property of equality, that says that if you subtract the same thing from both sides of an equation, it will still be equal in the end, right? I don't know if you've seen this, but Mr. Wood's got like a little scale thing next door. A little balance beam. I don't know if you saw his new balance beam. I like to think about it as like a balance scale. I don't know if you've seen one of those things. Let's say I have like some unknown weight and then like 2 pennies, and then I've got 9 pennies over here. And I want to know how many pennies does this unknown weight equal. And it's currently balanced, meaning these 2 sides are equal, right? You would be allowed to say, well, I'm going to take away one of these and one of these. Is it still going to be balanced? Yes, as long as I remove the same thing from both sides. And likewise, if I remove one of these and one of these, I end up finding out, hey, it's still balanced. And better yet, I found out x is equal to 7. All right? So that's why I subtract from both sides and why I'm able to do that. Okay? So I know you've probably seen this before. I'm just starting us off nice and slow. Oh, that's an ugly E. Ugh. So let's see. Let's say I've got this problem. 3x plus 2 equals 11. So 3x plus 2 equals 11. Could you describe to me what is happening to x? And it's having that happen in that exact order, right? According to order of operations, right? If x was like some number we knew, if x was 5, I wouldn't do 5 plus 2 and then multiply by 3, right? I'm multiplying by 3 and then adding by 2. So if I want to undo those things, I actually want to undo it in the reverse order. Okay? Right? Like if I assembled some sort of weird bomb trap or like something like that, you'd probably have to dismantle it in the reverse order that I mantled it. I don't know if that works. But anyways, yeah, thanks for taking care of that. So what we're actually doing, instead of order of operations, PEMDAS, we're going to SADMAP. We're Sally, Aunt, dear, my excuse, please.
You're gonna like slam it.
You just pull it tight, and then you gotta sneak away sometimes. Like, use your stealth. Yep. There you go. If you move too quickly, the floor creaks and translates those vibrations over to the door frame, to the hinges, to the door, and then it reopens. Yeah, I'm telling you. Telling you. Classic. So, we're sad mapping here. So I want to undo the stuff that's happening to x in the reverse order as the order of operations. So if you were to solve this, which thing do you want to get rid of first? The 2. How do you get rid of the 2?
From both sides.
From both sides, and we're allowed to do that because of the subtraction property of equality. Right? And now, how do I get rid of the 3? Because x is being multiplied by that, so to undo it, we divide. We cool? Are we cool, people? And there we go. Right? And I can divide both sides of an equation by the same amount, and I'll end up with the same thing. Actually, to verify, let's say I had 3 x's on one side, and I had 6 pennies on this side. All right? And I've got my little scale that's balanced. Excellent scale. And I said, okay, I want to find out how much 1x weighs. Well, I could think of these as 3 groups, and I could group these into 3 things, right? And I could say I'm going to get rid of one group. I'll get rid of one group, get rid of one group, get rid of one group. And I see that 1x is worth 2 of those, right? So the idea of division, as long as it's done to both sides, also seems to make sense. Isn't it wonderful? Good stuff, good stuff. Let's see, I think I want one more problema. Let's say I've got 2/3. Oh, that's a loop-de-2 for sure. That's a loop-de-2. Well, it's not Waldo until I hit 2 different 2's. Yeah. So 2/3 x. Let's do -7 equals 5. That'll do. That'll do, pig. So here we go. So could you someone describe to me, what is happening to x this time? What do we got? Yep.
It's being divided by 2/3 and then...
No.
Or 7 is being subtracted from it and it's being divided by...
No.
Multiplied by 2/3.
Multiplied by 2/3 first, and then 7's being subtracted from it. Right? So I actually like that he recognized 2/3 as just being a number. That's what I like. I mean, I myself, I like fractions. You might even say I'm a fractionophile. Maybe. I know most people hate fractions, and for some reason they specifically think that some numbers are better than others. But I'm like, no. Let's be cool and not hate on some numbers just because you don't get along with them, right? Like, we got to learn to understand each other here and not just hate the things we don't get. Am I right, people? Come on. So another way that someone might describe this is they could say x is being multiplied by 2, divided by 3, and then subtracted by 7. Or they could have even said x is being divided by 3, multiplied by 2, and then subtracted by 7. But I kind of like dealing with that all at once. So what thing should I undo first? And to undo subtraction by 7, I'm going to add 7. Seems like the opposite thing to do. Okay. And let's see, we said we're being multiplied by 2/3, so to undo multiplication by 2/3, I should divide by 2/3 and then throw up. Blech, that's terrifying, right? I mean, well, maybe you know a good strategy for dealing with that. That's a fraction within a fraction? Whoa. That's,
Inception.
yeah. Wow, inception, I like that. Actually, there is this concept of 1 plus, what's the formula? R over 1 plus R over 1 plus R over 1 plus. And it goes on infinitely. That's scary. Yeah, that's scary math right there. But that stuff does exist. But yeah, dividing by a fraction just feels weird. So let's not do that. Does anyone know an alternate approach we could use? Multiply by what? Tris- Perfect, right? So he described it in 2 steps. He said we could multiply both sides by 3 and then divide by 2. All right? And that's perfectly fine. I'm going to get rid of it all in 1 step, which is multiplying by the reciprocal, all right, which actually is the same thing. It's multiplying by 3 and dividing by 2, right? So flip and multiply is what I used to have a math teacher say when I was in high school. And it always sounded like she was yelling at us saying, flip and multiply? Right? Like, it's like, whoa. Yes, bless you indeed. Bless you indeed. So check out what happens over here. The 3's cancel out. The 2's cancel out. And over here, you could do 12 times 3 divided by 2. You could do 12 divided by 2 times 3. And I kind of like this cross-cancel technique. 2 goes into 2 once and into 12 6 times. And then 6 times 3 is 18. So I kind of like that one myself. And there we go. So it's not terrible. It works okay. No es más mal, as one might say. But yeah, so this is just a basic introduction on kind of translating equations from sentences, getting a little used to some of the vocabulary, and then also solving as kind of thinking about it as undoing the things that happens to X. Well, thank you, Internet friends. I hope you all had fun. You should click like and subscribe to my channel. Bye-bye.